So let's talk about three variable simultaneous equations, right? Okay. So there are two ways, actually three ways you can handle this. One is by substitution, one is by elimination, and one is by matrices. Actually four, even Cramer's rule as well, which of course is a bit connected to matrices. Okay, so I'll start first of all by handling these three by elimination. Okay, so the basic concept of elimination has been covered earlier. Okay, so you can watch the video, the link is in the description, about basic elimination method. So let's apply it to three variable simultaneous equations. So I'm first of all going to get the first two, okay, and just rewrite them. So we have 2a plus b minus c is equal to -1, and then we have a plus 3b minus 2c is equal to -6. I can actually do it twice, right, at the same time. Let me do it simultaneously from the question itself. So I've first of all written the first three. I can do the same for the last two. I can write them somewhere there. But on paper, of course, you go step by step. Okay? I'm just trying to give you an overview so that you understand basically a summary of the steps involved. Okay, so in simultaneous equations, you have to ensure that the variable that you're trying to eliminate should be of opposite sign and then of equal magnitude or size. Alright, so in this case, I would prefer eliminating, okay, any letter. I'll eliminate C. Let me eliminate C. So for the first equation, I can multiply the first equation by a 2. So this is negative. So I want that one to be positive, so I'll multiply by a -2. So we're going to have -4a minus 2b. I'm multiplying the entire equation by -2, so and then we have got a positive 2c and then a positive. For your -1 is a positive 2. And then the other equation will just be the same. A plus 3b minus 2c is equal to -6. And then we can actually just subtract. Or we're actually adding. -4a plus a is a -3a, right? And then -2b plus 3b is just a b. And then 2c minus 2c is a 0. 2 minus 6 is a -4. Okay. By the way, another alternative way, instead of multiplying by a negative sign there, just multiply by 2 and then come to subtract. You still eliminate. Okay, no harm. Okay, and then let me look at the other two as well. So I have to eliminate C as well, so that I can have simultaneous equations having A and B alone. So I can just multiply the second equation by 2, so that we can have 2C and -2C. So the first one will be maintained. A plus 3b minus 2c is equal to -6. And then we have 10a plus 4b plus 2c is equal to 10. Right? We've multiplied the second equation throughout by 2. And then at this point we can now just add a plus 10 is 11a, 3b plus 4b is 7b, -2c plus 2c is a 0, -6 plus 10 is a 4. So we now have two simultaneous equations. So for elimination method, I don't need to keep any of these. Just eliminate them all. They are not important. Well, on your paper, if you've written that, you're still going to have your information, which is still fine. Okay, so I still want to deal with simultaneous by elimination, right? So which one can we easily eliminate between A and B? Let me eliminate, since I can eliminate B. So I'll just multiply the first equation by 7, right? So we're going to have -21a plus 7b is equal to negative 28. And then we have 11a plus 7b equal to 4. Okay, so since these are of the same signs, I would have to subtract instead of adding. So negative 21 minus 11a gives me negative 32. Yeah, 7b minus 7b is 0, negative 28 minus 4 is minus 32. So our a becomes 1. Okay, so we found the value of a. Since I want to deal with this purely by elimination, I can still proceed and perform elimination and eliminate b again. So negative 3a plus b is equal to negative 4. 11a plus 7b is 4. Let me try to eliminate. I'm trying to eliminate a now, right? So I'd have to multiply that one by 11 and this one by 3. So 11 times 3 is negative 33a plus 11b minus 4. And then you have 33a plus 21b equal to 12. So we can just add negative 33 plus 33 is 0, and then 11 plus 21 is 32b, and then negative 44 minus 12, or negative 44 plus 12 actually. You can think of it as though you're subtracting, but get the sign from the bigger number. So that's going to be like 32, but negative. So b becomes negative 1. So we found the values of a and b, and then we can now try to find the value of c. So there is no other way but substitution. So we can get an equation of our choice. So I'll get the first one, 2a plus b minus c. Since we found two values, a and b, we can find c by substituting. So our a is 1, our b is negative 1, our c is what we're trying to find. So I have a 2 minus 1 minus c is equal to negative 1, and then you have 1 minus c is equal to negative 1. At this point, you can make c the subject, so we have a 2 equal to c, okay, by adding a 1 both sides, and then also adding a c both sides. Okay, so c is equal to 2. So our answers are a is equal to 1, b I believe was negative 1, and then our c is equal to 2. Okay, so you can actually prove this by trying to substitute in any of the equations. I can substitute in the last one, 5a, 2b, and then c. So 5 minus 2 plus 2 is 5, which agrees with that, right? Okay, and then let's do an example about dealing with it in terms of substitution purely without elimination. Okay, so let's consider x plus 2y plus 2z is equal to 4, 3x minus y plus 4z is equal to 25, and then 3x plus 2y minus z is equal to negative 4. So let's try to solve this one using substitution. Okay, so I would have to get the first two equations, okay, and then of course, in fact not the first two, I'll get the first equation and then make any letter of my choice the subject. So I would go for x right away, and obviously you know why. So my x becomes 4 minus 2y minus 2z, right? Okay, I've made x a subject. So I'll now substitute this in the next equation. Okay, So let's do that. So we have 3. Now I have as x, I'm putting 4 minus 2y minus 2z. And then don't forget, now we have minus y. So minus y plus 4z is equal to 25. So what do we have now? So we have a 12 minus 6y minus 6z minus y plus 4z is equal to 25. Any like terms? Negative 6 and negative y, negative 6z and 4z. And then of course 12 and 25. So negative 6 minus y is negative 7y. 6, negative 6z plus 4z is just a minus 2z. And then on the other side, 25 minus 12, because we'll add a negative 12 both sides. So that's going to be a 1 and a 3. 13, right? Okay, so we've come up with one equation by using the first two. Let's do the same by getting the second two. So I'd have to make again x a subject in the first equation. Let's just do that. So we have 3x being equal to 25 plus y minus 4z divided by 3, right? So the 3 there will divide, and then you just remove the 3 there. And then get the second equation and substitute. So I have is x, I'm going to put that 25 plus y minus 4z over 3, which is good, right? You know why it's good? Because it's going to cancel. I don't like dealing with fractions. So plus 2y minus z is equal to negative 4. This and this will divide. So we have 25 plus y minus 4z plus 2y minus z is equal to negative 4. Okay? Any like terms here? So we have 25 and negative 4. So we'll subtract by 25 both sides. Okay? And then y plus 2y, 3y. Negative 4z minus z is minus 5z. And then we'll subtract by 25 both sides. So negative 4 minus 25 is negative 29. Okay, so we now have two simultaneous equations. So my recommendation is each time you're dealing with simultaneous equations, better you start with a part which is having a bigger number. So I'll start with one that's having a 29, because it's going to be easier to compute that way. So we have, now if you check again, we have is y. There's a big value there, so I'll deal with 5 instead. Okay, so I'm going to make z the subject of the formula. So we're going to have negative 5z is equal to negative 29, and then minus 3y. We can divide the entire equation by negative 5. So our z is going to be negative 29 over negative 5, then minus 5, negative 3y divided by negative 5 again. So at that point, our z becomes 29 over 5 minus 3y. So it's going to be positive as well, over 5, which we can just combine and just have a common 5, right? Okay. So we can now substitute in the other equation the value of z. So the value of z, let me have that back. So that's a case where I've made z the subject. Okay. So that's over 5. And then now we're trying to substitute here. So I have negative 7y minus 2. So for our z we have 29 plus 3y. And then we can just combine the common denominator 5. is equal to 13. Okay. So what do we have? Negative 7y, and then multiply by the 2. So 29 by 2 is what? 58. So minus 58, and then minus 6y, of course. This is all divided by 5 is equal to 13. Okay, so want to make things easier, we can apply the entire equation by 5 so that the fraction can disappear. So we're going to have negative 35y, and then the other part to just be minus 58 minus 6y, and then 13 as well times 5 is 65. Okay, so let me take just the z part on top here. Alright, so I'm saying our goal is to find the value of y. So 55 plus 6 is a 41, right? 55 plus 6, this part and that, so negative 41 y, and then we can have the other side 65 plus 58. So 65 plus 58, 65 plus 58 is a 123. So 123 divided by 41. So negative 41, y is equal to 123. Then y becomes negative 3. So found y to be negative 3. And then you can try to find z. How are we going to do that? So you can just get to the point where our z is a subject, just on top there, right? So our z is equal to 29 plus 3 times negative 3 for y, and then over 5. So 29 minus 9 is a 20. 20 over 5 is what? Is a 4. So we have y negative 3, and then z is 4. We can find our x by getting to this point. Or you can get any equation of your choice and just substitute. So 4 minus 2y, y is negative 3, our z is 4. So we have 4 plus 6 minus 8. 6 plus 4 is 10, minus 8 is 2. So x is 2. Okay, so you can verify using a different equation if your answer is true. So 3x, that's a 2, for y, negative 3, for z, minus 4. So 6 minus 6 minus 4 is equal to negative 4, which verifies.